Hi everyone, my name is Arkadiusz Borucki. I work in Munich, Germany for Amadeus IT Group as Senior NoSQL DevOps Engineer. Today I will be talking about MongoDB on Kubernetes and about MongoDB Enterprise Operator for Kubernetes. I'm happy I can talk to you on MongoDB Live 2020. Let me introduce Amadeus to you. We are the leading technology company dedicated to the global travel industry. According to Forbes, in 2019, we were in world's top 10 software companies. 1.9 billion passengers has been boarded with Amadeus software solutions. 645 million total bookings has been made using the Amadeus distribution platform. We are present in almost 200 countries. Billions of travelers is using Amadeus solutions every year. We shape the future of travel. I will start with MongoDB Farm at Amadeus, and also I will tell you a bit about our MongoDB use cases. We will talk about Kubernetes operators and also about MongoDB Enterprise Operator. We will deploy Ops Manager with MongoDB replica set on Kubernetes, and at the end we will build simple database as a service which can run on multiple cloud providers. I hope you will enjoy my talk. MongoDB at Amadeus. At Amadeus, we are running the biggest MongoDB farm in Europe. We divided our databases between 8 ops managers, which are running in multiple data centers. It can be main data center in Munich, it can be data center in Frankfurt, it can be data center on OVH or in public cloud. We are running the biggest MongoDB cluster in Europe, which has 110 terabytes of data. We shard this cluster and deploy across 63 physical machines. We have very good performance results on this cluster. We also use microsharding. We run up to 68 MongoDBs per one machine. We are using huge hardware with 1 terabyte of memory, and one MongoDB would never utilize resources. That's why, after benchmarking, we decided to put 68 MongoDB processes to make sure we utilize our hardware as much as possible. In total, we run 6,500 MongoDB processes distributed across all phases. We are also in the cloud on GCP and AWS. For private cloud solution, we use OpenStack. MongoDB use cases. The most famous use case is MongoDB instant searching flight recommendation data. Every time when you use Skyscanner or Kayak, you are searching your flights in one of our huge MongoDB clusters. Currently, they have 110, 190, and 75 terabytes of data. We refresh data in those clusters by daily basis, which means we delete old records and inserting documents with new prices. Our customers are able to search flights with 3 milliseconds average response time for reading. Second famous use case is MongoDB MSX with 168 shards on 6 servers. I was talking about this microsharding on my previous slide. If you want to get total number of MongoDBs which are running on this cluster, you need to multiply it by 3, because we are using replication for our shards. Digital Intelligence Hub. That's an example of single view application which is running on MongoDB cluster. We aggregate data from multiple sources and we push this data into central cluster. we are able to run very interesting analytics queries for our customers. We also run Apache Spark's jobs on MongoDB. This is fraud detection project. We use MongoDB for MongoDB Amadeus payments flows as main database. Also, we use MongoDB for many internal tools like dashboards, scheduling tools, change viewers, application or error viewers. Every year we have more and more use cases. The future. Let's talk now about the future. Kubernetes. Everyone knows that Kubernetes is the future of the infrastructure. But what are the operators? How can we use operators? Operator is a controller which extends the Kubernetes API. With help of controller, we can run MongoDB specific objects on Kubernetes cluster, like replica set, like ops manager, like standalone or shard cluster. We can also use ops manager features on Kubernetes cluster. Mongo operator currently supports stateful sets for replica set, which means you can have persistent storage for your database on Kubernetes. Creates ops manager on Kubernetes cluster. Creates deployment in ops manager. Provides backup, automation and monitoring for your database pods. Automates cluster provisioning, scalability, auto-recovery and logging. Automates common tasks to achieve the desired state. Also provides security. You can enable TLS. And in the future, much more features will come. Operator is the way to teach Kubernetes about MongoDB. That's hard-coded knowledge about how to operate MongoDB on Kubernetes. Running stateless application on Kubernetes is relatively easy. But if we are talking about databases which have state, they are stateful, it becomes much more complex. Fortunately, Kubernetes provides stateful set API object, which can be used for stateful applications like database. MongoDB operator is taking advantage of stateful set and provides stable, persistent storage, graceful deployment and scaling for your MongoDB database. Also provides rolling upgrades and unique network identifiers. Let's have a look on this picture. That's high-level overview. On the left-hand side, we can see operator mainfest. Operator via service catalog builds MongoDB namespace on Kubernetes. If we look at the bottom on this picture, we will see stateful set. And we will see that stateful set is main actor for this action. Stateful set via persistent volumes claim is claiming persistent volume. Persistent volume can belong to different storage class. This is actually depend on cloud provider because different cloud providers offers different storage classes. Also, when you run your cluster on premises, you need to declare by your own your storage class. Stateful set also bind pods into persistent volumes. Operator also expose your pod via service to external world, which means you can access your database even from outside of Kubernetes cluster. Operator architecture. Operator is nothing else, just a pod which is running on Kubernetes cluster and extend Kubernetes API by additional objects, like for example, Ops Manager. That's why we can run Ops Manager together with his application database, which Ops Manager is using for metadata, also on Kubernetes. When we have operator up and running and Ops Manager, we can start deploy MongoDB database. So we need to prepare YAML file with desired cluster state, and via kubectl apply, we need to trigger Kubernetes API and tell Kubernetes to deploy object kind MongoDB type replica set. Let's have a look. Operator will deploy 3 pods in this use case with MongoDB image, which have automation agent built in. That's why we can see those pods in Ops Manager UI or REST API. And that's the way how Ops Manager can install MongoDB database on those pods via agent. Operator will trigger Ops Manager REST API, and Ops Manager will start database installation and deploying additional agents, which are backup agents and monitoring agents, because automation agent is already there. And this is how simple it is. This cluster now would be ready to use. Operator elements, custom resources. It can be kind MongoDB with type replica set, standalone or shard cluster. And if we want to deploy Ops Manager on Kubernetes, it can be kind MongoDB Ops Manager. You need to also specify desired Ops Manager version, external connectivity, in this case load balancer, because we want to access Ops Manager from outside. Also, Ops Manager must have application database. This application database will be also deployed on Kubernetes in version 4.2.2. Second element is controller. That's a loop which will check actual state, analyze difference from desired state, and if this is necessary, we'll take that action, which means we'll drive actual state into desired state, and repeat. Observe, my replica set has just 2 running pods. Analyze, desired state is saying that we need to have 3 pods. Act, take an action. Start a new pod, add pod to the cluster, wait for replication, and repeat. Controller will be always checking desired state against actual state and will take action just when necessary. Live demo. Let's start with live demo. We will deploy database as a service on Kubernetes. Let me explain you steps. We will deploy multiple Kubernetes clusters with help of Terraform and Rancher on AWS EKS, Google GKE, and also on AWS EC2 instance. So we will have 3 different Kubernetes clusters. Those clusters will be managed and controlled as one cluster from Rancher UI. We will also create custom resource definition for MongoDB objects, which will be Ops Manager and replica set. We will create Ops Manager fully managed by Kubernetes operator as a pod on Kubernetes cluster. And also we will deploy MongoDB replica set with persistent volumes via operator. When everything will be ready, we will scale up MongoDB, and we will execute database upgrade. On this picture, I will show you steps. With help of Terraform, we will deploy on AWS Rancher with 3 Kubernetes clusters, one of GCP, one of EKS, one of EC2. On EKS, we will also deploy MongoDB database with Ops Manager. Let's start. We see that we have Terraform provider for Rancher. I think now we can run Terraform init. Message is saying that we are ready for deployment. The Terraform apply will create for us Rancher Cluster Manager, which will be running on EC2 instances, plus 1 Kubernetes cluster, which in this case is running on EC2, but this cluster can run everywhere, including bare metal cluster. So Terraform started his work. It should not take long. So at this moment Terraform is talking to AWS API and creates resources for us, and it is ready. So here we have URL address to our Rancher server. Let's open it into web browser. So UI is visible. Now we need to log in. And we see 2 Kubernetes clusters. First one, local, is running Rancher application. Here we can see that there is etcd, controller manager, scheduler. If we go to kubectl, and we will try to display all pods which are running on this cluster, we will see that we have 3 Rancher pods. So we are connected to one of those pods. Second cluster is MongoDB RKA cluster. So you can create such cluster on AWS or on Google or Azure, or also on bare metal machines. But this is not what we want to do today. We want to deploy 2 more Kubernetes clusters. From this place, we can deploy Kubernetes on every cloud provider. I will choose Google GKE for the first cluster. This will be very easy. We need to just put desired cluster name, which is MongoDB GKE. I need to import my service account credentials. And now I'm able to choose desired state of my cluster. I can also do this via Terraform, but I want to show step by step how to do this. For demo, I will just use a small VM with standard persistent disk. This cluster is not the best one for databases, because we should choose SSD. And cluster is provisioning. So now I want to create second cluster, and on second cluster I will deploy MongoDB Ops Manager with MongoDB database. I choose AWS AKS. Here I'm putting again cluster name. I'm choosing region. Now I need to copy my super secret public and private access key. And now I need to configure desired cluster state. So I want to have Kubernetes in version 1.14 with standard VPC. I want to have bigger EC2 instances as nodes for my Kubernetes cluster. I want to have in auto-scaling group 3 nodes, and I think 20 gigabytes for persistent volumes will be enough for this demo. And I'm creating cluster. So 2 clusters are under provisioning now. Maybe let's check in AWS console what is going on. So we see that AWS API has been triggered and cluster is in creation status. If we go to compute, there is nothing because compute needs to be deployed. Okay. So now cluster become active, which means is available. Let's check if we have nodes. We have 3 running EC2 instances as we request M5 8x large with different availability zones. So now we see that all our Kubernetes clusters are ready to use. Let's check GKE. So we see classical Kubernetes namespaces, 3 nodes as we requested, and let's see storage classes because every cloud provider has different. So here we can see standard storage class. Let's check AKS. Here we can see that we have GP2 storage class. So this is SSD disk. Also we have 3 nodes. We saw this already in AWS console, and we have classical Kubernetes namespaces. Here we see etcd, controller manager, scheduler, and Kubernetes nodes. If you want to see events on our Kubernetes cluster, we can scroll down and see everything what is going on our cluster. Okay, let's go to shell. We can display our pods. So currently there is nothing related to MongoDB, but we are going to change this. I will follow this MongoDB block running MongoDB Ops Manager in Kubernetes. Also for examples which I will use today, I will be using this block. It's very good for start. You can also go into MongoDB official GitHub account, and here you will have many samples. So you will have step-by-step guide how to start with MongoDB Enterprise Operator for Kubernetes. And if you go to samples, you will find Kubernetes clients, MongoDB, and Ops Manager. In MongoDB, if you, for example, want to deploy replica set with persistent volumes, you have ready to use YAML file, which you need to just copy and apply into your Kubernetes cluster. You will create kind MongoDB, which will be visible in Ops Manager with persistent storage, which will use stateful sets. Okay, let's come back to our block and let's do instructions which are there. Create MongoDB namespace. Let's copy it and execute in our Kubernetes. So we see that MongoDB namespace is created. Let's check namespaces and MongoDB is visible, which means first step is done. Second step, create custom resource definition, which means if we want to extend Kubernetes API, we need to execute custom resource definition YAML file. Let's see what will happen. MongoDB objects has been created. MongoDB users resource definition, Ops Manager resource definition, and also MongoDB webhook. Now we need to create MongoDB Enterprise MongoDB Enterprise operator with necessary Kubernetes objects. It's looking good. Let's display our pods in MongoDB namespace, and we see MongoDB Enterprise Operator, which is running, which means Kubernetes API has been extended by MongoDB specific objects. And now we can create Ops Manager on Kubernetes. We need to create a secret. I prepared this in a separate file. I will just copy paste this file. Secret has been created. Now I need to prepare Ops Manager YAML file and just apply it to Kubernetes. So this file will have desired Ops Manager state together with application database. Let's have a look inside. We want to create object kind MongoDB Ops Manager in namespace MongoDB, desired version 4.2.1. We want to have load balancer because we want to access Ops Manager from outside of the Kubernetes. And we must have application DB for metadata with 3 members. And soon this will be running on Kubernetes. Now just simple kubectl apply, and let's see what will happen. First Ops Manager node, first and second pod has been created. Let's have a look into operator logs. This is the best place to see what is going on or maybe debug some problems. But at this moment we see that everything is running well. Application database is under creation. If we go to persistent volumes, we see that operator created 3 persistent volumes for 3 application database replica set members. And now 3 members are almost completed. In logs, we can see that stateful set is not ready yet, which means operator is still provisioning stateful set for replica set. which means our application database will have persistent storage. This is fully automated with operators, so you don't need to worry about stateful set. And now, last pod, which is Ops Manager itself, is initializing. And it is ready. So now we have Ops Manager with application database up and running on Kubernetes. Open your application. Actually, now we need to take Ops Manager URL and use this URL for communication with Ops Manager from our web browser. Let's copy. So this is why we need load balancer, because now we can connect from our web browser into Ops Manager, which is running on Kubernetes. We need to register, like we always do on Ops Manager with first user. This is standard procedure, we need to just do this. There is also a possibility to automate this via Ops Manager REST API, but for this demo, I just want to show you how to do this manually. Now we need to just fill necessary fields, just those ones which are required, because this is test cluster, so we will not set up any security or any features which are necessary to run production. You can just continue on those pages. Our Ops Manager is ready to use. You can also see pods here in this UI. Here is Ops Manager and 3 members of application database. Okay, let's come back to our blog. We did step with UI. Now we can remove secret, which we create 2 steps before. So now, if we have Ops Manager up and running, we can create MongoDB replica set, MongoDB database. First of all, we need to create a REST API key for Ops Manager, because we need to be able to access Ops Manager REST API. So I will generate key MongoDB Live 2020. Here is my API key. I will copy it for later. I need to put IP address into API whitelist because I will not be able to hit Ops Manager REST API. I will choose 192.168.0.0/16. It should be okay. Now I need to create a secret. I have this also predefined in my notepad. So I'm creating generic secret. I will show you later why I'm doing it. Now I need to create config map with Ops Manager internal URL address. This will be used by automation agent to connect to Ops Manager from MongoDB cluster. I'm preparing command. Okay, and now last step, we need to prepare YAML file with MongoDB object definition, which means we need to prepare YAML file with desired MongoDB database state. So what I want to have? I want to have object kind MongoDB with namespace MongoDB, of course, type replica set, and here I want to put Ops Manager config map, which I created a step before, and credentials, which I created 2 steps before. So this replica set needs to connect to Ops Manager via those credentials and with help of this config map. And here also we can see that I want to have persistent true, which means I want to use stateful set to provide persistency for my pods, for my database pods. Let's apply this. And now let's see what will happen. So operator together with Kubernetes is creating my replica set pods. Let's go to logs. We see that operation is ongoing, no errors. More pods popping up. If you go to persistent volumes, we see that 2 additional persistent volumes has been created by operator, which is very good. Let's go to logs once again, and we will see messages related to stateful sets, which means operator is creating again stateful set for replica set. So all this complex operation has been automated. We don't need to know how to do this. If we go to Ops Manager projects, we also see that operator created project in Ops Manager, and we see our pods there, and now Ops Manager is installing MongoDB database on them. This is what I was showing on slides. And we are ready. We have monitoring, backup, and automation agent ready to use. Let's see activity feed. And here we can see what exactly happened, what exactly operator did via Ops Manager REST API. If we want to connect to our MongoDB cluster, we will get ready to use connection string. So cluster is ready, we can connect our application and we can make some tests. But what if we want to upgrade our cluster? We just need to change one number in our YAML file. So we want to go to version 4.2.6, which means we want to do minor upgrade. And kubectl apply. Now operator will trigger Ops Manager REST API and will tell Ops Manager to upgrade MongoDB cluster to version 4.2.6 in a rolling way, which means there will be no downtime. And we see that first pod has been upgraded. Now second one, so we do one at a time. Second one is upgraded, and now the last one. And we are done. We had rolling update without downtime because update was executed in rolling way. Okay, let's think now what we need to do if we want to scale up our cluster. So let's say we want to have 5 replica set members, not 3. We don't need to know how to do this. We just need to specify desired state. And the controller will check desired state, which is 5, against current state, which is 3, and will take an action. Exactly like on slides. So now additional pods are starting. Here we see our well-known message that stateful set is under provisioning for this pod. If we refresh Ops Manager, we see that we have one additional member which is visible. Last one is almost ready. As expected, we have more persistent volumes. Created by operator, so we don't need to do this manually. And let's refresh this once again. And now what we can see, that pods are visible and Ops Manager is replicating data to them. Cluster was empty, that's why it was fast. If we refresh this, we see that our MongoDB database has been extended from 3 to 5 pods without any big problem from our side. Now we need to finish soon, so let's delete our MongoDB replica set. So we see how easy it is destroy your environment if you don't need this anymore. So you don't need to pay for unused resources. So cluster is almost decommissioned. Now just Ops Manager left, so let's destroy also Ops Manager, just kubectl delete, and operator together with Kubernetes will take an action which will destroy our resources. Okay, now also let's destroy our clusters because we don't need them anymore and we don't want to pay for it. This is also very simple. All clusters has gone. Summary. Kubernetes is the future of the infrastructure and we all know about it. Running database workload is possible on Kubernetes with stateful set. Operators reduce time, cost, and management complexity, as you saw on demo which I did for you. Scalability up and down is very quick and easy with operator. You need to change desired state and controller will drive all changes on your behalf. If you have good software-defined storage on which you can run your database on Kubernetes, you can achieve very good performance results, which it makes alternative for classical deployments, which means you will spend less time on infrastructure management and more time on application development. Thank you very much. It was a pleasure for my side to talk to you on MongoDB Live. I wish you all the best and I hope we will meet each other next year. Thank you.